Okay, I think we out here. Let's make sure that we out here. Looks like we seem to be out here. I'm going to put these guys on number three. Actually, let's throw that over there. Let's pop OBS over here. Oops. Can we do this? Can we do this nicely? Like this. Yes, like this. Move that there. Move that there. Okay, where do I see views? Okay, right there. 0 views. Concurrent viewers? I guess that's the current viewers? This microphone's in an odd place, I realize. I'm gonna mute it real quick so okay, I hope I don't end up bumping this or anything like that. Okay, that should be good. Oh, I have the wrong description here. Programming. Ah. Eh. Beautiful. That's it. That's what you want right there. That's what we're doing. We're programming in OpenGL and Assembly. I have to leave. When do I have to leave? I need to keep note of this. It's going to be around 8:30, so we got an hour and a half. Okay. So we're working with OpenGL and Assembly. We're using the fasm assembler. We're not doing much in the way of like macros with fasm. We're defining a few symbols and things here to make things easier. And probably I'll get into doing a lot more sort of macro-driven assembly programming soon. At some point, but it feels I want to learn assembly first before I learn the nice bells and whistles. I love it so far. I've been just basically doing nothing but calling OpenGL functions and GLFW stuff to get windows open and stuff. So I just managed to. What did I do? I have the texture. Oh, so what we're doing is I'm going to be making a software renderer of some kind. So we have a screen texture with OpenGL, and we have a quad mesh, and we have a shader program that we have created here. And that should be all we need to just draw a back buffer to the screen that will supply pixels to manually. So let's see if we can make that happen now. So I've just done the initialization stuff, and none of the main loop stuff. So where is our main loop? There it is. I'm going to say loop begin. I think that sounds better. Might even want a loop end at some point. We'll see what we end up doing. We're going to do loop begin, and let's make sure that our program is working. We got a little purple background. We're on X11 right now for the Windows system, which is that's what we're doing. We're gonna eventually do Windows as well. Although I'm gonna try and get sort of a minimal working example going here in Linux, and then try to see what is required to make that work in Windows. Windows has some quite sizable differences in the way the assembly works, like the calling conventions and stuff like that. I have foolishly not looked much into that, and so we're just going to deal with the pain when we get there. If it involves a complete rewrite, then we will learn something. we will have learned something. Okay. Okay, so what I'm doing is I'm going to get open my one of my older projects and just look at what was done there to sort of follow along in the realm of assembly. Let's do this. Let's move this over here and let's open up a Firefox. Move that there, and we'll just have OpenGL functions and stuff like that right there. Okay, so this is not where I want to be. I want to be in the renderer. Right. Okay, so yeah, are we calling GL clear yet? Where's our loop? Okay, so we have the window should close stuff. If it should close, we move to our exit. All right, this is us moving the clear color into the situation, and then we're calling GL clear, and then we're swapping buffers. So here, to do draw quad. We have a nifty little code generation situation happening here where we have a shader. You know, we have a couple shaders here that are just, you know, these are just straight up copied from Learn OpenGL just to see if they would compile properly. And then we have that gets generated into this stuff here, which is just a bunch of bytes written in hexadecimal, and those are just being printed out into a big line, and then that gets included here. That's another one of the fasm macro stuff that we're doing, and so then that gets used. So the shader code is part of the executable. Okay. I need to not explain things. I just need to program, in fact. Especially because nobody's watching. I mean, why would I be talking if nobody's watching? Okay, so we have a pixel scale here. I suppose that's something... How do we want to do this? I'm thinking we probably will do a fixed resolution. So what I'm eventually going to do is the plan is to make a sort of voxel cube. This is something I've done before in just like regular OpenGL. Sort of do some sort of voxel cube grid thing with some little shapes inside, and it's going to be sort of a pseudo path traced situation going on. And so there will be a sort of solid border color around the outside, or rather there will be a solid color in the background. And so I reckon we can just have that be the clear color, the GL clear color, and then we'll render the quad at some... It's going to be pixelated, so sort of low resolution thing, and so we'll find some multiple of the the sort of logical resolution that fits inside of the screen size, and then we'll just draw it in the center. And then it can just be like a 4:3 aspect ratio or even a square aspect ratio. So we don't really need a notion of pixel scale, really. That can just even be hard-coded into the shader if we wanted. So yeah, so we don't need any of this. This is all stuff about this pixel art game I was making. And then we got some stuff. This is an SSBO, which we do not need. Okay, so we need to... Basically, this stuff is it. That's all we need right there, and we don't need to draw arrays instance. We just need to do the most of that stuff basically the same. Okay, so I like to get my calls set up here first to be clear what I'm doing. GL use program. GL. We do not need to bind buffer base. We need to bind the texture. We need to bind the vertex array, and we need to GL draw arrays. That's what it is, right? GL draw arrays. Excuse me. Yeah, so I don't know what I should do here. I guess I think triangle strip. Triangle strip? Or maybe just GL triangles. I'm going to do GL triangles. Yeah. Okay. So let's do, is that really all that we'll need? Use program, bind texture, bind vertex array, draw array. Yeah, I think so. Okay. So we do already have, okay, so we should have, the program and the VBO should be in, that's actually funny. I can rework my compile shader code because I should really have the program here in my global data. Okay, so that's going to be RD1. And so in my shader program, I had a whole thing where I was putting the program into R12 and then passing that into a compile shader function, but I just do not need that, as it turns out. GLVBO. Yeah, okay, so GLVBO, right? R13. In fact, yeah. This is R12, so we don't even need this at all. We don't need R12. So let's also, okay, yeah, we'll do GLVBO, and then let's go ahead and move these down just to make it clear that we are not using R12 and R13. So in our compile shader function, we no longer have the program ID being passed in. So we don't need Here's where the assembly gets assembly-ish. Okay, 0x10. So this is attaching the shader to the program. We just need this to be program. Did I say VBO up there? It should be program. Yeah, program. And then in compile shader we have GL 0x10. 0x10. I just realized, do we have... Ah, I see. Okay. Okay. It's kind of hard to talk while programming in assembly, I realize. I actually thought it would kind of make it easier because I would be able to, talk through all of the different, registers and stuff that are being used, and it might make it a little clearer in my mind, but it's really just like a lot of, it's just saying like all of these abstract numbers and, registers and offsets and stuff, I feel like is actually making it more complicated. Okay, so 0x10. So program ID was only used once, which sounds correct. So really, we need to just move all of this down. Okay, we just need to move all of this down by 1. Man, that is error prone. So the 18s become 10. Okay. 18s become 10. Okay, and then I shouldn't say 18, the 1/8s, and then we do have the 10s. Okay, and then the 20s become 18. I'll just say 18. Okay, 18. Okay, let's see if that works. Okay, so operand sizes don't match. Okay, yeah, fair. So then we need EAX, not RAX. This should also be, well, okay, let's just to make sure as well, because I know I'll need to, we don't have these arguments set up, so we shouldn't be calling them. Let's just, what was that again? It was at 169. So that should be EAX. Okay, same. Oh, no. RDI. Okay, yeah, that's what I figured, that we would get that one. So it should be EDI. Because it's a 32-bit integer, so it needs to move into a 32-bit register. Okay, well that worked, seems like. Okay, so that seems to work. So now, well, that wasn't too bad, was it? Okay, so let's do our use program. Use program just uses the program ID, move RDI, EDI, I should say. EDI GL program. Ah, I see, I don't have these. Oops, GL use program. That should do it. Ah. GL bind texture. Oh, fair enough. Fair enough. Bind vertex array. Cool. All right, so we're working. We're working. Okay, so GL bind texture then. Move. I still don't remember the registers. Okay, RSI. What am I doing? Bind texture? Okay, so we want the texture ID. So GL texture. And then RDI, we want GL texture 2D, right? GL text 0x. Ah! We just basically want that same line. Whew, okay, I need a better way of getting around this code base. Okay. Okay, we're binding the texture. That should work just fine. Oh. Yep, okay, yep, same deal. Honestly, I should be using the E registers, the 32-bit registers for the other stuff too. That's probably, you know, I don't think it matters, but, you know. Okay, so that works. GL bind vertex array. Once we get to the actual program running and the arrays being drawn, I'm not sure exactly what will happen because I just put these guys in from learn OpenGL, so we'll probably need to change something there. Quad VAO, so VB, oh, interesting. VAO, that's what I'm supposed to keep. Is that what I did? Yeah. GL, VAO, I'm doing it again, EDI. RDI. Okay, good. I just hadn't saved it. All right, and now for the main attraction, move RDX. No, RSI then RDX. Oh no, yeah, RDX. Yeah, got it. RDX. What I don't remember. Where am I? Okay, right now over here. The mode. So we need GL. Oh, you know, we also need another OpenGL situation. Open here. Cube Games extern. Gonna have this open so I can look at GL things. Yeah, sure. Okay, grep. We're looking for GL triangles. It's going to be 0x0004. RSI, right? Okay. First, specifies the starting index. Starting index is 0. The count is, no, not 1. It's, how many? It's going to be Vertzlen, I think I called it. Vertzlen. Oh, draw arrays, right? Okay. Okay, so it did nothing. So let's see why. Let's see why it did nothing. Screen.vert. So we've got, so this is a vec3, but it should be a vec2. A position 0.0. Yeah, let's do that. Okay. One thing that we need to do is we need to build in the generation into the make file here. So let's just do that real quick and dirty. Well, no, let's do this properly. Let's say, in order to have these things built, we need to, in order to build this, we need to have that, and then we need to also have code/generation, what is it called? Generation, and then generated data. And we'll say that's going to be cd code/generation, yeah, and make, yeah, right? That makes sense. Okay. Make sure that we're calling this. We are calling this, right? Okay, we are. We are getting here. GL triangles, and we're specifies the starting index. Yeah, it should be 0. We've got our verts. We should have done that. Okay. Might be time for. I mean, I'll look at this first. So vertex color is vec4. Frag color is vertex color. Shaders vert. We've got our apos. We're doing this. We're doing this. All right. Well, let's get render doc open and see what we can see. Cube games. Okay. What do we got here? Oh, interesting. It's black on the first frame. That's kind of interesting. It's because it's swapping the buffers before it even does anything? Or what? Pipeline state. Interesting. Nothing's getting actually called? Oh, weird. Okay. Okay, so bind buffer. It says no resource. GL array buffer. GL bind buffer. Oh, okay, hang on. So, okay, so this is the beginning here. Vertex array. Bind vertex array. I don't know how to look at the actual thing. Okay, let's see the mesh view. Okay. Okay, so let's go here. So GL draw arrays. It says 4, which seems very, very wrong. Very wrong. I wonder why it's 4. Well, I'll take a look at that. Okay, GL draw model. I wonder what 5161351 means. I'm not really sure. Oh, what are the issues? No vertex shader bound. Oh, interesting. Haha. Okay. GL use program. GL create program. Thinks there's a UV binding. That's kind of interesting. Okay, so draw arrays. So again, GL create program. Am I not able to see what the actual shaders are? Apparently not. Yeah, no resource. Okay. So we've got some very serious issues, my friends. This is probably going to take a while to fix because it indicates that I've been doing some things very, very wrong. Okay, so we have our texture, our VAO, and our program. And those are all a D word, which is, of course, a 32-bit integer, unsigned integer. I do wonder, like, there's no signed integers, right? I mean, there's no such thing as a signed integer. I mean, obviously there is such a thing as a signed integer. I just wonder how you actually define that sort of stuff in fasm signed integer. Let's see what DuckDuckGo's search assist has to say. Well, okay, whatever. Assembly signed integer. so very helpful. Okay, so when we create the program, we're creating our things. We got R12 and R13. We link the program. Yeah, and we've attached them. Where does the attachment happen? There it is. Program and shader. Yep. Is it a big problem, perhaps, that I'm using the 64-bit stuff when I really should be using the 32-bit stuff? Maybe it is. Maybe it is. So vert's length here is 12. Vert's len is 12. I don't know if literal is the proper word here. Yeah, maybe it's probably very important that I'm using the 32-bit instructions, which is a hell of a pain here because I've been fucking around with that all damn day. So what we need is, let's do this. So let's just, I think almost all of these, it's going to make sense to use the 32-bit ones. So let's go. And we want that for sure. So any of the pointers. Invalid operand. Oh, ha. Well, okay. Oh yeah, yeah. Or R8D. It's gonna be called, isn't it? Yeah, R8. Yeah, R8D. R8D. Okay, so that's still working, and we're still called the right thing. We are good, so that's working. So GLFW window, that's going to, okay, so we're moving into GLFW window. Oh, which makes sense. We want that to be a 64-bit thing. Yeah, RQ. That makes sense. Okay. Where do we go? Okay. RDI. We're going to say, let's do EAX, you know? Why not? That makes sense to me. We're still working. We're still working. All right, so move into RSI. Okay, RSI, that makes sense. We want the even we'll get an error if we do ESI here, right? Oh no, we will not. That's dangerous. Okay. That's okay though. So we've moved GL gen textures. What we need there is we need the pointer. So we have a pointer. So we're doing that. So we're doing that. Very good, very good. And then okay, we're doing that already, which is nice. Let's do E for that. We don't really care that much about the texture stuff right now, I suppose, in a way, but still. Maybe we should be saying D word. Except for on this one. Yeah, all right, okay. E. Is that not how this works? Push. Yeah. Yeah, that's fair. We're not able to push anything other than the register size. I suppose we could just, you know, make stack space and then put it in there, but I don't really think that's very important, to be honest with you. Add RSP32, that's good, that's good. RSI, yes, we want that. EDI. Excuse me. Let's do E12. EAX. And we'll say E. Yeah, we want that and that. R12D? Is that what we're called? Is it R12D? I should just keep this open. R12D. So then what's our issue here? Oh, well, it's not even the right thing. Okay, 149. So E12, R12D. Okay, we're still here. We're still here. We're still out here. E, R, okay, we want R and R there. 32-bit, 32-bit, the length. So those are both pointers, yeah. Those are both pointers. EAX. Okay, this is the actual value, so we need E. We already did that. Cool. That's a pointer. Okay. E. E. Oh. Yeah. That's a GL draw arrays. That wants the count. Oh. Oh, I see. That's why the verts length was 4. It's because I was putting the address, not the value of the length, the verts length. Okay, so we're gonna go with RDI there. Maybe. Okay. Segmentation fault. All right, segmentation fault. So we have verts length, which is of course a DD. Let's see where that seg fault happens. Let's see where the seg fault occurs. No, let's do okay, we're gonna just go to, let's go down to GL attach shader. Weird. Where's my oh, we're up here. Okay. Okay, let's do this one. BR 0x 4014BA. Okay. Now we want to refresh, and let's say next instruction. Clear is working. Clear. Use programs working. Bind text. Bind vertex array. Okay, draw arrays does something weird. So what's RSI at that point? Do we know at this point? I set ESI, GLint, GL size I. Okay, so the count is supposed to be, I think, a 64-bit integer. I don't know if that's exactly what's going on here, but yeah, size I presumably is a 64-bit integer. Yeah, so let's make this a 64-bit integer, and then we'll have some other issues. Hello. So this is the ESI, and so we'll do let's say GL buffer data. GL buffer data. Oh, that's interesting. Yeah, size. Okay, size pointer. Okay, so even here it's supposed to be a thing. All right, we're gonna do this again. Hey, where are we at here? What the hell? Program no longer exists. All right, let's do this again. All right. So let's go link program clear. Okay, so we're gonna say BR 0x 401 4BB. Oh. Okay. debug. ER 401 BB. Ah shit, what was it? 4 BB? Maybe? Maybe. Alright, we're good. Alright, so we did that, we did that, we did that, we did that. Clear color. Clear. That's fine. Use program. Bind texture. Bind vertex array. GL draw arrays. It's usually int. Interesting. So it's actually not 64 bits. Am I able to, I'm not able to go up and down from here. I don't understand why that is. So we're gonna need to, you know, move in here automatically. Okay, so we're gonna step into so again, I just pushed this the vert's length is, oh, you know what I did? I did it the wrong way around. I did it the wrong way around. That's kind of funny. It's kind of funny. So I did, yeah. So I did mode first count. So where did it go? Where'd it go? Where'd it go? Right here. So triangles, did I? Yeah, mode is first. Oh. RDX. It is RDX, right? DISIDX. Okay, first is 0. Whew, you know, that is really interesting, I suppose. I just want to make sure that, because I'm passing a 64-bit integer now, is it going to actually do this? Like, is it going to just do the lower 32 and then not set the other, and then we'd have like uninitialized data in the top one and blah blah blah. It's GL size IPTR. What is pointer bits? The bit depth of a CPU pointer address. Okay. Okay, so so that should be fine then. In this particular case, it should be fine. Okay, let's make sure we got this right. So first is 0, and that's correct, and that shows so that should be correct, and it's still fucking us. Let's bring these back down. Let's bring this back down to an integer, because I just feel that makes more sense. Okay, so we're still seg faulting. Okay. So So where's our thing? We're gonna draw array. So BR right? Yeah, 151A. What? Oh, 151A. Ah! Zero X 40151A. What? I cannot access memory at blah blah blah. All right, we're gonna just. I think I guess I already screwed it up. Okay, so I'd like to see if I can make this process better as well at some point. BR 0x401551A. Okay. Refresh and then next. Step into. I don't necessarily know what's happening at the moment, that's for sure. This is interesting. It's screwing around with the R12 through R15 registers, and I thought that those those registers were supposed to be not screwed around with. Anyway, at some point this is going to crash, and I won't know why. That's for sure, because I don't know. You know. I don't know what's happening. You know what I should have done is I should have taken note. So my okay, what do I got? RDI, RDX, RBX. So 0x4. So my RDI, which is mode. Yeah, that makes sense. That makes sense. Mode is triangles. RDI is mode. First should be set to. Ooh. Is RDX correct? No, it should be, yeah, RSI is what I'm looking for. Where is RSI? There you go. Set to 0, yeah. Okay. And then the next one that I should be looking at is DI-SI-DX. DI-SI-DX is 12. Okay, yep, that's right. Except again, these are supposed to be actually integers. I should take a look at this in no, because it's crashing now, so we won't even know, because the call to draw arrays doesn't even go through. I wonder if however, it will be able to. I don't really know what happens when you launch a crashing application, like while it's in a GL call to render doc. Let's see what happens. Nothing. It doesn't know. It doesn't know. That's fair. It cannot do anything. Okay. Man, we are crashing. We are crashing when we try to draw the arrays. Why weren't we crashing the other time, I wonder? we are giving them the count, the actual value of count, which seems correct. We are putting the first blurst. When we do the buffer, the buffer data, kind of maybe should be, it kind of maybe should be 64 bits. Yeah, let's make sure we're correct here. GL static draw, yeah. Yep, makes sense, yeah. Size. And then the data. And the data should be good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let's do this. Let's just not do the draw arrays and then see what RenderDoc thinks we're doing. Okay, that works, which is good. Let's go to RenderDoc. We'll give it a go. We'll see what we're doing here. Hello. There you go. Okay. Pipeline. Okay, so vertex array. Do we have it? Can we reach it? Doesn't say. Okay, bind. Where is the call to buffer data? Bind buffer. Bind vertex array. Where's bind buffer? That should be here, right? Does that not get shown in RenderDoc or something? Or did this never get called? GL bind vertex array. Let's capture frame 0. GL swap buffers, GL clear. I do find it very interesting that that swap buffers and stuff is getting called, and clear is getting called before everything else. Like, is that just what happens with GLFW? That would be interesting, wouldn't it? It'd be very interesting, you know? GLFW init, create window. Glue init. Oh yeah, so make context current. Yep. Glue init. Okay. We're never calling GL viewport. I don't know how important that is. Covers the entire window. I wonder why it seems to follow the window, or it seems to follow the window moving. Like, yeah, because we don't really have a. I guess GLFW poll events might do that. Interesting. Very interesting. I don't really know why it seems to be working then. Okay, well, anyway, let's go back to what we were doing. So we were looking at this and making sure that it's all good. Yeah, so we're creating the shader, blah, blah, blah. Gen vertex arrays. Do we have gen vertex array? I mean, we do gen buffer. Is that right? No, okay, we are doing that. VAO, bind it, and then gen buffers. Ugh. Mm-hmm. Enable vertex. So we go right from, I think, bind vertex array to enable vertex attrib array. Capture frame 1. Oh no, let's do this guy. Okay. Yeah, so bind vertex array, enable bind vertex array, enable vertex attrib array. Yeah. Weird. So like the data never gets buffered? What version of OpenGL am I using, and is it the same version that I've used in other projects? GLX version is not the same thing as GL version. 4.6. Oh, okay. I think I'm doing 3.3 on this, which is not what I meant. Let's do 4.6. Let's go with yeah. So 4.6, please. Seems a little hardcore to be good doing such a late version, but okay. So we've got that. So now let's try this again. Let's see what happens. All right, we do sag fault still. Let's see what happens if we render dock it. Okay, nothing's still on the thing. So let's do frame 1. Oh. Did I do frame 1? That's frame 0. Okay, let's just do this again. Oh, what? Oh, okay. I don't think that I compiled it. Okay. So GL use program, blah, blah, blah. Okay, still the same where it's like not capturing all the events. Why is that? Why is that? You know? I wonder if this has these same general issues on one of my other. Oh, do I not have fuck. Okay. All right, this does say core profile not explicitly requested. I wonder why that is. How do I thought that I did explicitly request core profile, but let's see what it's got here. GL use program, GL bind buffer. We got loads of calls to GL viewport, which is interesting. Yeah, let's try frame 0 here first. All right, so this one has GL buffer data and stuff. Oh, but it's for the uniform buffer. Or no, it's just, yeah, this is for yeah, interesting. Let's let's take a look here. Let's take a look. Let's make sure I'm doing this all in the correct order. Let's in fact do this on the Potemkin side. Code render. So with the renderer, we are doing the vertex. Okay, program vertex object UBO. Okay, so let's do vertex object. So we generate the vertex arrays. Where are we here? Okay. Generate vertex arrays, bind vertex arrays, gen buffers, bind buffer. Okay. Yes, I see. This right here ought not be the VBO. We need to load the effective address here. Yeah, in fact, GL gen buffers doesn't even return anything. Isn't that interesting? Okay, there you go. That'll do it. Okay, R12. Is going to be the VBO. Well, okay, let's just see what else we've got here. So the VAO is put in there, which is good. That's what we want. We want the value of it for bind vertex array. We want to load the effective address of R12. R12. Load the effective address of R12. I guess it doesn't matter. But yeah, okay, so good. So where are we? GLGen buffers. Blah, blah, blah. GL bind buffer is GL array buffer. Oh, dude, I got some of these backwards. Oh no, dude. Okay, so one good. Yeah. Oh, dude. Oh, that is scary, man. Okay. For the bind buffer, we want it to be the actual value of our 12D. Yeah, that makes sense. Yeah. R12 though. Yeah. No. R. Yeah. Okay. GL bind buffer. Well, let's see if we did any of the other ones wrong. So we've got GL buffer data. Looks like we did that one in the correct order. 1, 2, 3, 4. Static draw. Verts length. Oh, okay. No, that's right. That's right. Verts length times vertex size. Aha. Okay. Okay. All right. So now we have to do some actual assembly programming, which is fun. So let's do. Where are my guys? My guys. We're using all the way up to. Let's just use RBX. Why not? Okay, so mul. Unsigned, blah, blah, blah. I would love to just, I just need I need to print out a manual. We've got ourselves some advertisements playing. So interesting. AL. Dude, that is just, get out of here. Something's going on with my web browser. I don't know why it doesn't want to do anything. Are we okay here? What's going on? Can I also not look at this while I... I'm glad that that's been muted. I guess I wouldn't... Well, no, I would have known, obviously. Okay. Are we good? We good? Okay. Oh, AL. Oh, I see. So that was just using those. x64 mul instruction. good. Unsigned multiply. Okay, so it multiplies the first and the second and stores it in the first. Okay, so where am I here? So we're going to move, what is it? What was I going to use? RBX. RBX, that's going to be verts len. Okay, and then we're going to mul RBX with, well, it's going to be 4 because it's the size of an F32, and an F32 is 4 bytes. And then we need this to be, in fact, RBX. Does that work? Extra characters online? What are you talking about? Do I need to, like, yeah, mul. Well, I wonder why, what imul, oh, imul is signed, perhaps? What do you mean, extra characters? Fasm extra characters on line. What if I just add a comment? Hello. Dude, I told you never to do this, you fuck. Can I just say, like, 0x 04? Rit? Okay, I need to learn about that at some point. I'm gonna make a note. Okay, operand sizes don't match, so we just need this to be EBX. Oh, well, fine. Okay, let's go EBX. Okay, segmentation fault still occurred. In fact, it occurred, it's a new seg fault. It is a new seg fault. Ah, fuck. Okay, so where are we here? call these save registers, meaning they're saved across function calls. Are they really? So let's try mool again, you know? I wonder, extra characters online. Does that just like, okay, so mul is only takes one? Only takes one? Table. You see that? Destination times equals source. Oh, destination's in the at the end. Interesting. Unsigned full multiply. Same effect as imulq. Signed full multiply. I wonder what full multiply means. So the destination's at the end on imul. So we need to do that. Does that work? Is that a thing? Oh yeah? Imul for ABX. Invalid operand. Let's just do this. Isn't that interesting? So we're making it there. We're seg faulting on gen buffers. So I screwed up. GL gen buffers. Did I actually get this wrong now? Let's try this. Let's try this. Push, and then let's just say RSP is our thing. And then we'll say RSP, and then we'll add. Oh, we didn't get there, obviously. Okay. So we just can't push in a register, which makes sense, obviously. We can't push a register as a pointer. Can I push register as pointer in assembly? Pass. That does seem obvious that I can't do that. Yeah, you know, totally. Okay, so So where are we? So I just did, so we've done this. So we subbed and added, make space for VBO pointer. Don't need VBO anymore, I don't think. R12D, right? Okay. We're back. We're back in business, baby. Now what happens when we call GL draw arrays? Okay, we're running from the law. Oh, that's okay. Wrong program. Okay, frame 0 as usual is probably not going to have much of anything in it. I still would like to figure out why that is at some point. Okay, so we do our swap buffers, we do our draw arrays. So it's drawing 12, which is good. It's drawing 12, which is good. The vertex array, gen vertex arrays, sounds good. Okay, let's go to our pipeline here. Oh, well, okay, yeah, what do we got here? It says still no vertex shader bounded draw, so we do need to fix that as well, obviously, which is its own thing. So what are we doing here? So we've got our buffer. Can I view the contents of the buffer, maybe? 0, 1, 2. Ha! That doesn't seem large enough right there. 12 bytes. Okay, so buffer data, 12 bytes. So that did it, that was incorrect. That was incorrect. It only buffered 12 bytes of data, which is not enough. So EBP, I think probably that, yeah. It's because we haven't, oh! How about that? Dude. That's interesting, especially because we apparently don't have a, it could not inject itself. Okay. Okay, well, we've made some good progress here. I think I'm going to end it here. Give myself a little bit of time to get ready for work. And then yeah, we'll come back and see what else we can do. Have a good time. Oh, I didn't